Good morning. Here is our project titled as Treatment of Industrial Dye Wastewater and Adsorption Kinetics, guided by Usha ma'am, myself, Pranavpathy E.K., and my friends Saravanapandian and Sridar. Here is a short introduction of our project. Our project is mainly based on adsorption technique, which is of high efficiency and low cost, which is nothing but the surface property. We have used three materials here: activated carbon, chitosan, and starch, which are good adsorbents. Adsorption is good technique and it has a great thermal stability and a good adsorption capacity. Here is a problem statement of it, which is nothing but the untreated textile wastewater discharges into the rivers and ponds. So we have the solution is that already I have said that the three materials we have manually prepared a pellet and same as that of the powder using different ratios. Here's a short literature review on it. We have done totally 15 literature studies, and the research gap of it is that activated carbon has some limitations such as high cost. So have been done for an alternative absorption material, which is nothing but chitosan added with the activated carbon plus starch, which is used for killing neutralizing negative charges. And the project objectives of it is totally four. Here, the method is given as a top-down approach, activated carbon. Here it is the picture description of it.
So these are some of the initial tests which we carried out in the raw sample. As we already said, we have made pellets in different type of ratios. The ratios are 1:1, and 2:1 is picturized here. The next is the 1:2:1, 1:1:2. So these ratios are nothing but activated carbon is to chitosan is to starch. So we have finally derived that the pellet which containing the ratio of 1.5 is to 1:1 is more efficient, and it has given the best results in absorption. As we have collected the sample from the industry, we haven't determined the color of it. So by UV spectrometer, we have determined the wavelength of it. We have obtained the maximum value at 504. 504 is the range of Allura red, and it is the color of our sample. So with this, we have tested the water sample with powder and pellets with each ratios. Here we can see how much difference it shows in time interval where the sample is in with contact with both pellet and powders. Absorption is more in powder as the surface area is more in powder than compared to the pellet. And same method is carried out in all the ratios, and all the values are depicted here. So this is for each and every pellet we have done it.
The adsorption kinetics is the study of the surface characteristics of the material. We have done this adsorption kinetics for the adsorption process we have done before. So initially we don't know the concentration of the dye present in the water. So we are using the Lambert's equation for calculating the initial concentration, which is 2.445 mg per liter. For the best ratio of pellet 1.5 is to 1 is to 1, we are doing the kinetic study. For that, first we are doing the first order kinetic study, which characteristics of physical absorption takes place or not. We can see that the correlation coefficient R square value is 0.51389, which is not even closer to 0.999. So this does not meet up to the criteria. So here the physical absorption does not take place. So we are going for the second order kinetics. So here we can see that the correlation coefficient R square value is 0.98796, so which is nearby to 0.999. So here the criteria is accepted, and the process adsorption take here is the chemical adsorption, not the physical adsorption. So we are doing the same for the best powder ratio of 1 is to 2 is to 1, resulting that chemical adsorption has taken place in both pellet and powder. So this is the category where we are going to publish our journal paper. Thank you.